Hi, Mr. Richards here, and today's lesson is on translations. It's our first in our series of transformations. Now, a transformation is an operation that maps an original geometric figure, the pre-image, onto a new figure called the image. Now, a translation slides a figure from one position to another without turning it. Now, if you were to scan this lesson and complete this graphic organizer on translations, hopefully you would find these things. If we were to define this in our own words, a translation is a slide without turning or flipping. Hopefully you can remember, or you'll learn later in this chapter, that turning is a rotation and flipping is a reflection. Now, three characteristics. First, the shape stays the same. Next, the size stays the same. And last, it faces the same way. Now, this graphic organizer includes an example and a non-example. Well, if we were to take this original triangle here and translate it, we'd want to try to keep the same size without turning or flipping. And that might be a little smaller what I drew, but it's pretty much the idea. Now, a non-example, well, what if we drew it like this? We've moved the location of that right angle, and so we've rotated it, and that's not a translation. Now, the real world link. Carmen created the design at the right on her computer. Describe the motion involved in moving the design from A to the new A, with this being our A and this being our new A. Well, it looks like we went over to the right one space and then down one space. So that's what we can write. We can say over one space and down one space. Compare its size, shape, and orientation of the design piece in its original position to that of the piece in its new position. Well, the size, it's the same. The shape itself is the same, and the orientation, the direction it's going in, well, you see the down arrows pointing down both times, so this little thing sticking out to the right. So the orientation is the same, and so we can just simply say they are all the same. Now, translations in the coordinate plane. When a figure is translated, the x-coordinate of the pre-image changes by the value of the horizontal translation A. The y-coordinate of the pre-image changes by the vertical translation B. So if we're saying we're going to the right 4 units, that 4 units is going to be our A. So we can take the x-coordinate and add whatever A is going to be. Same is true with our y. As it says, when translating a figure, every point of the pre-image is moved the same distance and in the same direction. The image and the pre-image are congruent. Congruent figures have the same shape and same size. So line segments in the pre-image have the same length as line segments in the image. Angles in the pre-image have the same measure as angles in the image. And now, what you see with these little dashes, these are actually called prime symbols. You're going to use prime symbols for vertices in a transform image. So, looking up here at our example, the blue triangle is our original image. And notice how just A, B, and C, just like A, B, and C. Then we have our A with the dash, B with the dash, C with the dash, and this actually has a name. It's A prime, B prime, and this is probably supposed to be C prime. Here in our guided example, graph triangle JKL with vertices J at -3, 4, K at 1, 3, and L at -4, 1. Then graph the image of triangle JKL after a translation 2 units right and 5 units down. Write the coordinates of the vertices. Well, what you can see that they did here was each vertex of the triangle, the J, the K, and the L, got moved 2 units to the right and 5 down, and there's our new J. Our new K was 2 right, 5 down. For L, 2 right, 5 down for our J prime, K prime, L prime. And then, once you have these 3 points, you can fill in the lines. So it says, from the graph, the coordinates of the vertices of the image are, for J prime, -1, -1. K prime, 3, -2. And L prime is -2, -4. Now we can look to try one of these on our own. It says graph triangle ABC with vertices A, 4, -3, B, 0, 2, and C, 5, 1. Then graph, but let's graph our original first. Our A is going to be at 4, -3, so we'll go out to 4 and down 3 units, so that's 4, -3, and this is where it does become important to actually label these, so that's going to be labeled as A. B is at 0, 2, 0, 2, and we'll label this one as B. And then C is at 5, 1, 2, 3, 4, 5, 1, which is out here. And so that is our original triangle. You can actually connect these lines, or connect the dots here to get the triangle. Drawing as straight of lines as we can here. A little curvy on that one, but overall not too bad. We can see the triangle. Now it says, then graph its image after translations of 4 left, 3 up. So we're going to take each of these points, A, B, and C, and go 4 units to the left and 3 units up. We'll start with A, and we will go 1, 2, 3, 4 units to the left, and 1, 2, 3 units up. That gets me here at 0, 0. What about B? Well, for B, from here, 4 units to the left, 1, 2, 3, 4, and 3 units up, 1, 2, 3, and there's my new B, or my B prime. As for my C, 4 units to the left, so from over here, 1, 2, 3, 4, and 3 units up, 1, 2, and 3. Now I can draw in my line segments. You notice how our size is the same, the shape is the same, everything is the same except we simply slid the unit. Now, to rewrite these, we have A prime, B prime, and C prime. And our A is at 0, 0. Our B is at -4, +5. And our C is at 1, 4. So make sure if it does say to write the coordinates of the image, you're not done by just graphing. You actually have to write the units as well. 0, 0, -4, +5, and 1, 4. So that is how we can translate using the coordinate plane. There is another way that we could translate that does not involve actually putting it on a graph. In our example 2, triangle XYZ has vertices x, -1, -2, y, 6, -3, and z, 2, -5. Find the vertices of triangle x prime, y prime, z prime after a translation of 2 units left and 1 unit up. Well, it says we're going to use a table and add negative 2 to the x and 1 to the y. Well, why negative 2 to the x? Well, think about a number line. If you have a number line, and say we have numbers 1, 2, 3, and if we're sitting at 3, if we're going to go 2 units to the left, we're actually subtracting 2, or adding a negative 2. So that's why, if we're translating to the left, we can add a negative 2. And what about adding 1? Well, if you look at our number line going up and down, and you had 1, 2, 3, the same logic applies. If you're sitting at 1 and you want to go 1 up, you're at 2, or just adding 1. So that's why we're adding a negative 2 and adding a positive 1 to these coordinates. We don't even need to graph. And of course, our left to right movement is our x-coordinate, so we can take our negative 1, add the negative 2 to get negative 3. Our negative 2 plus 1 is negative 1, and so on for each of the points. Now let's try one of these on our own. Quadrilateral ABCD has vertices A, 0, 0, B, 2, 0, C, 3, 4, and D, 0, 4. Find the vertices of quadrilateral A prime, B prime, C prime, D prime after a translation of 4 units right and 2 units down. Well, let's figure out how we're moving. 4 units to the right. And if you need to sketch yourself a number line on these just to kind of see what's going on, go 0, 1, 2, 3, 4, and say, all right, if I started at 0 and I went 4 units to the right, I'm adding 4 to each of these. So for my x-coordinates, I'm going to add 4. And if you need to, you can still do the same for your units down. You just say, all right, 3, 2, 1, and you know you're going down, so might as well start at 3, and say, okay, I'm going 2 units down, 1, 2. Well, that's like the same thing as adding a negative 2. So our y-coordinates, we're going to be adding a negative 2. So now we can set up our table. We're going to have our vertices of ABCD we are going to take our x-coordinates and add 4. We're going to take our y-coordinates and add a negative 2. And then we will have our new vertices of A prime, B prime, C prime, D prime. All right. Well, for A, our original was 0, 0. And what are we going to do to our x and our y? Well, for our x, we're going to add 4. And for our y, which was 0, we're going to add a negative 2. And so the new point, 0 plus 4 is 4. 0 plus negative 2 is negative 2. So the new A, or A prime, is at 4, negative 2. What about B? Well, B right now is at 2, 0. And so we're going to take the 2 and add 4 to it. Then we're going to take the 0 and add a negative 2 to it. And so our B prime is going to be, no pun intended, 6, negative 2. What about C? C is at 3, 4. We're going to take the 3 and add 4 to the x. we're going to take the 4 and add a -2 to that. So our C prime is going to be 7, 2. And lastly, we have our D, and our D is at 0, 4. So we're going to take our 0 and add 4. Then we will take our Y, which was 4, and add a -2, so that our D prime, or our new D, will be at 4, 2. And that's it. I'm going to rewrite this A here with the A in front, just to model that a little bit better. The new A was at 4, -2. And so that's how you do this type of example without graphing. You simply add 4 to all your x's, add -2 to all your y's, and you come up with your new ordered pairs. Now, can we describe a translation? We can graph a translation on a coordinate plane. We can use arithmetic to calculate the new ordered pairs. Now, can we look at a translated image and say, this is what happened? A computer image is being translated to create the illusion of movement. Use translation notation to describe the translation from point A to point B. Well, point A here is located at 3, 3. Point B is located at 2, 1. And so our x, y, we're going to say, okay, this is x plus A, y plus B. So we have 3 plus A, 3 plus B, substituting in the 3 for x and the 3 for y. And we need to ask ourselves, okay, how did I get from 3 to 2? 3 plus what was 2? Well, that answer is -1. Then we have to ask ourselves, 3 plus what is 1? Well, that answer is -2. And this is where it comes in to be our translation notation. We're taking the x's and subtracting 1. We're taking the y's and subtracting 2. And that means 1 unit to the left and 2 units down. Let's try one of these on our own. So now we will refer to the figure in example 3. If point A was at 1, 5, use translation notation to describe the translation from A to B. Well, so our A is not going to be here anymore. It's going to be at 1, 5. So we can draw that in on the graph just to show this. And now our point A is located at 1, 5. And we need to somehow get this to our point B, which is at 2, 1 still. Now, let's go ahead and go through the process of writing this in translation notation. So we'll start this by saying, okay, xy is going to be translated into x plus A, comma, y plus B. I'm adding something to all my x's, I'm adding something to all my y's. What is that something is the goal we're trying to find. So we start off with the 1, 5. And we can put those in for our x and our y. So 1 plus something A, comma, 5 plus something B. And we need to use that to get to our B, which is 2, 1. Now, for our 1 plus A, 1 plus A, whatever I add there needs to get me to 2. And if you need to, you could subtract 1 from both sides here just to solve and say, all right, A equals 1. What about B? Well, whatever I do with 5 plus B, it needs to equal this point here, which is 1. And again, to solve this equation, you could subtract 5 from both sides, and b is going to equal 1 minus 5 is negative 4. So what this means now is that our translation is going to be whatever our x's are, we're going to add 1 to that. We're moving 1 to the right. And whatever our y's are, we're going to subtract 4. So that's our translation notation. If we wanted to write that in words, this would mean 1 unit right and 4 units down still. And that is it for this lesson on translations. Good luck.